Hi everyone, my name is Rachel Perez, and this is my Module 1, What is STEM? And just to introduce myself a little bit, I teach at Manheim Township High School. This is my 6th year teaching there, and I currently teach CP Life Science, which is like a freshman level science, and then Anatomy and Physiology is an 11th and 12th grade elective. Previously I've taught Honors Biology, CP Bio, and Biology Remediation. So why STEM? Kind of like how Jonathan Gerlach from NSCA said it, it's the next big thing. And when I was picking what I wanted to do for my master's, I saw that, there was a master's for STEM, and I was like, hey, that is the next big thing. It's going to help me further my career. It's going to help me stay up to date. It's going to help me to teach my students how to be successful with the skills that they need. And there's a lot of funding and grants that are involved in STEM. My colleagues and I actually just wrote one for some Sphero bolts, which I'll show you in a couple slides here. Hobbies and interests. I like running races with my friends. I do a lot of Spartan races, which are like obstacle races. I coach junior high basketball. I've coached for 7 years. I play soccer for LCFC, and I like to sew and be crafty. And now that we have those masks to wear, I have something to sew. Alright, my favorite cartoon character is a Minion. I even have one in my classroom. It's a little blurry, but I use it for my lab safety because a Minion is a very good example of what to wear for lab safety. Okay, so for part 2, before I even read the Vasquez book, it had a little note and said, come up with your definition for STEM, and so that's what I did. So STEM education is integrating multiple disciplines, science, technology, engineering, or mathematics into a lesson with the intention of solving a real-world problem. So this is the Sphero bolts that I was talking about, and if you've never used these things before, if you can get your hands on them, they are awesome. And so I have 2 lessons here that I did. The first one on the left here is a cell tour that I did with my life science kids. And so what they did was they programmed the Sphero to go through the cell. They could pick an animal or plant cell, and they had to program the Sphero to speak the name of the organelle as well as the function. Over here is what I did with my anatomy students, and they had to show me the path of blood through the heart, and then they had to somehow incorporate, so like you can't really see it, but on the Sphero it's blue right now, and so they're showing me that it's deoxygenated blood, and then showing me how it travels through the heart. So looking at Vasquez's chart of the connecting among the STEM practices, so I kind of just talked about the cell tour, and so they had to first gather the information about each organelle. So they had to do a little bit of research. They had to figure out what the function is, whether it was in an animal or plant cell. The engineering behind it was figuring out the path, so they, what order, and they could pick the order. There was no stipulations, and then how they were going to communicate the name of the organelle as well as its function. The technology was learning how to block program. So we used block programming for this particular activity, and we did a previous activity to have them play around with it a little bit and learn that. And then they had to figure out how to program the Sphero to speak the name of the organelle as well as speak the function of the organelle. And then the mathematics part was a little bit of figuring out how long it needed to roll, how fast, like the duration, and so there was a little bit of measuring and calculations with that. So why is STEM important? So I grabbed this chart here from an article that I actually read in another grad class, and it's showing kind of like routine and non-routine tasks. So routine tasks are like the if then and the step-by-step and the things that you do with a task list. And non-routine are going to be your more complex cognitive thinking, problem solving. So what it's showing is there's an increase in the non-routine, and so the demand is going to be for complex communication, expert thinking, and all of those 21st century skills that we're trying to teach our kids through STEM. Neil deGrasse Tyson said in his video, the innovations in creativity in science, technology, engineering, mathematics will be the drivers of tomorrow's economy, and so those are jobs, and that's what our students need. Is eventually when they leave high school, they're going to need a job, and so they need to learn these skills. From the other video, the National Academies of Sciences, Engineering, and Medicine, I kind of pulled a couple things. It's vital for our thriving economy and to make our society healthy, for our students to make real-world connections to situations, and to help our students maybe pursue a STEM course in college, or pursue, if you have STEM in your high school, or any career in STEM. And so these are my goals. I kind of just clumped them into 4 main goals. Successfully implement STEM practices into my lessons. I want to learn how to do that a little bit better. Make learning meaningful, so I want the kids to actually feel like they're doing that lesson for a reason and they're learning it for a reason. Establish relevance of STEM for my students. That kind of goes along with making learning meaningful, but show them like, hey, if you want this career, STEM's probably involved. And to grow and develop my own STEM literacy. And these are all of the references that I used. Thanks.